Hey everyone, welcome to today's lesson. Today's lesson has to do with derivatives. Um, and I'm also going to actually post a Khan Academy lesson on this also. It's going to be just an alternate explanation to what I'm explaining right now. So yeah, I'm going to make this video in two parts. The first part is explain the slide on what you see. And the next part is going to be examples of actually doing work. Okay, and again, the Khan Academy video is going to be alternate explanation to this current video that you're watching, which is an explanation of the slide that you're currently seeing. Okay, so derivatives is basically a fancy word for slope at any point. Okay, so um, I'm gonna create some. Let's create some purple dots. Okay, let's go with orange since that hasn't been used here. Okay, all right, let's go like that. All right, so I'm going to draw some lines that touch the orange dot. So here is a line that touches the orange dot. Okay, let me do a different color here. Um, let's go. I'm going to actually make all these purple. Purple, 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 purple. Okay, and let's go ahead and make the line also purple here. Okay, so purple, purple. Whoops, let me do that one better. Okay. And all right. So those those purple dotted lines that I just drew are called tangent lines. Okay, are called tangent lines. Those are lines that touch, okay, only one point. Okay, only touch one point. Okay, this black dotted line is a tangent line. This purple, 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 purple dotted lines are all tangent lines. Okay. The blue, green, and red, those are not tangent lines because they touch 2 points. The blue line right here, let's start with the red. The red dotted line connects the red and the black. The green dotted line connects the green and the black. The blue dotted line connects the blue and the black. So the red, green, and blue, once again, are not tangent lines. Those are called secant lines. Okay, secant lines touch 2 points. Okay, red, green, blue. Secant lines, black, and all purples are called tangent lines. Okay, so derivatives are basically slopes of tangent lines. That's it. Okay, so the slope of this purple, 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 and black, I should say, or black, are all derivatives. Okay, so derivative of this purple dot is the slope of that purple dotted line. The derivative of this purple dot, okay, is going to be the slope of this tangent line. The derivative of this black dot, okay, would be the slope of the black tangent line. Okay, so let's pretend this coordinate, I'm going to make something up. Okay, let's say this was 2 comma 3. Okay, so you would say the derivative of x, the derivative at x equal to 2 is going to be, let's pretend the slope was 3 over 4. Okay, let's choose completely different numbers. 4 over 5. Okay, so you may say the derivative at x equal to 2 equals 2 is 4 over 5. Okay, all right. Okay, so now that we got those out the way, okay, um, so again, the derivative is the slope at certain tangent lines. Okay, so the derivative would not be, okay, of there wouldn't be a derivative of the blue dotted line, the green dotted line, or nor the red dotted line because those are secant lines. Those touch 2 points. Okay. Um, so basically, here is the big picture. Okay. Now, I want you to right now, I want you to ignore these purple, these purple dots and purple slopes. Okay. Right now, we are interested in finding the slope of this black line. Okay. We're trying to find the slope of this black line. Okay. This black dotted line. So you can see a pattern that as you start from the red, go to the green, go to the blue, okay, um, that you get closer and closer to the black line. That's the first thing I want you to notice, okay? The red is really, the slope of the red is really far off from the black dotted line, okay? The slope of the green dotted line is less far off, or it comes closer to the black dotted line. And the blue comes yet again closer to the black dotted line. So long story short, the closer we get, okay, from red, green, blue to the black, okay, to the black dotted line, the more the slopes start resembling the black dotted line. That is really the theme of this whole slide. Okay? That's the theme of this whole slide. Okay? So now I'm going to call this x coordinate, I'm going to make something up. Okay, if this is x, this is going to be x plus 4. Okay, x plus 4. All right. And then if this is x plus 4, if you want to find the y coordinate, you put it into the function, okay, f of x. But you're putting in you're not putting in x, you're putting x plus 4, okay, into the function. Here, okay, I'm going to call this x plus 3. Okay. And then again, to find the y coordinate, you put x plus 3 into the function. Okay, so you get f of x plus 3, and the same idea goes for the blue. Okay, and you can keep going closer and closer. You can go x plus 1, okay, and then f of x plus 1, and then you can even keep going 0.9, f of 0.9, all the way until we want to see what happens, okay, when this number right here, okay, keeps shrinking, and gets all the way as close as possible to 0, which brings us basically to x. Okay, so which comes as close to possible to x plus 0, or just x. Okay, all right. So here's the deal. Let's start easy. Okay, this is your equation for slope. Okay. All right. Slope is basically rise over run. I should have probably written that. Rise over run. Okay, I should have written that also. Rise over run. Okay, which is this equation. You learned that from IM1. So if you were to find the slope of the red, you would do this. Okay, the slope of the red dotted line would be y sub 2, which is this, y2 minus y1. Okay, that's how I got this. Ignore the yellow highlights for now. Okay, don't worry about the yellow highlights. In fact, let me just get rid of them. Okay, let me get rid of them. And we don't need this. Okay, and so y2 minus y1 is the same thing as this minus that. Okay, x sub 2 minus x sub 1, okay, is going to be, this is x sub 2, x sub 1, going to be this minus that. Okay, boom, boom. All right. Okay, now these x's cancel, and you're just left with that 4. Okay, and then I just copy the top. Okay, now the same idea happens. Okay, the same idea happens. Let me ungroup these, ungroup that. Okay, let me just actually erase this. Erase that, erase that, erase that, erase that. Okay, the same idea basically goes for the green dotted line. Okay, these two are related. This is going to be y sub 2. Okay, y sub 1. Okay, and this is going to be x sub 2 and x sub 1. Okay, boom, boom. And remember, the x's cancel, you're left with a 3. Okay, so now the blue dotted line is going to be the same exact logic. Okay, you're going to be saying y sub 2 just moves here, x sub 2 just moves to the blue x plus 2 right there. Okay, all right, folks. So basically, let me actually just keep that there. Okay, here is the thesis. Okay, the thesis or the theme of this whole slide. It's right here. Okay, basically, we are interested. Okay, we are interested in these numbers right here. Boom, 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 boom. Okay, we're interested in these numbers approaching 0. Okay, we're interested in those numbers approaching 0. Again, we want this to approach 0. Okay, so that we can get closer and closer to this black dotted line. Okay, the closer these numbers get to 0. Okay, the closer these dotted lines, okay, the closer these dotted lines start resembling or becoming the slope of the black dotted line. And that's what we're ultimately after. We're after the black dotted line slope, the slope of the black dotted line. Okay? All right? Okay, I'm going to say it for the third time, and I hope you are getting bored of me saying this because that means you're getting it. Okay? We want these numbers right here, 432, 432, to start approaching to 0. Okay? Because as it approaches zeros, these colored dotted lines, red, green, blue, start becoming closer and closer and resembling this black dotted line, okay, which is what we're after. We're after the slope of this black dotted line, okay? And so that is basically what this equation is all about, okay? This equation is basically this equation, except instead of using 432, they're using a variable called h. And again, they're interested in h approaching 0. Okay? All right, because as h approaches 0, we start getting closer and closer to the slope, okay, of this black dotted line, which is what we're after. Okay, these colored dotted lines, red, green, blue, start resembling the slope of these colored dotted lines, red, green, blue, start resembling the slope of this black dotted line. Okay, so folks, again, I'm going to post another video of Khan Academy explaining this. It's going to be an optional video. You do not need to watch it if you understand what I said. Okay, and I know I repeated myself many times in this video, but that's because I really wanted to drive home this concept. Okay, now I'm going to post another video after this about of doing some examples on how to use this. Okay, so we are basically trying to find the slope at any given point. Okay, I like to call the instantaneous slope of this black dot. Okay, the instantaneous slope of these purple dots. Okay, they are the slopes basically of the tangent lines to the purple, black. Okay, instantaneous slopes are basically the slopes of the tangent lines of any particular dot. All right, folks. Thank you for listening in.